A machine smaller than your hand is quietly reshaping the world. Every AI chatbot, image generator, and self-driving system depends on chips like these. Long before metal is cut, every curve, every bolt, and every wing is perfected inside powerful computers. Modern airliners aren't built from ordinary metal. They're crafted from aerospace materials strong enough to survive decades of extreme pressure, yet light enough to fly.
Hold position at grid C. Confirmed clearance on the left side. Proceed slowly.
Before a single bolt is installed, lasers measure every surface to microscopic accuracy. Even a tiny misalignment, millions of rivets hold this giant together. Every single one must be installed with extraordinary accuracy, because there are no second chances in the sky. Everything you've seen so far was only preparation. Now comes one of the most breathtaking moments. The wings don't simply bolt on. They must fit with astonishing precision, because these structures will soon battle storms at 40,000 feet. The airplane is finally beginning to look complete. But the heart of this flying giant hasn't even...
Each engine weighs several tons, yet it must be positioned with millimeter precision. One small mistake here could delay production for weeks.
These connections will withstand thousands of flights, violent turbulence, and incredible forces, all without failure. But here's what almost nobody knows. A modern Boeing contains hundreds of kilometers of electrical wiring, hidden behind the walls that you'll never see. This cockpit is the aircraft's brain, processing thousands of signals every second to keep every flight safe. Everything you've seen so far was preparation. Now the giant receives the legs that will support hundreds of tons during every landing. These wheels may look ordinary, but they absorb incredible impact every time the aircraft touches the runway. Slowly, an empty metal shell transforms into a space where hundreds of passengers will soon travel across continents. However, appearance isn't enough. Every seat, every latch, and every emergency system must pass rigorous inspection before anyone steps on board. The next machine is even more unbelievable. In just hours, this unfinished aircraft will receive the iconic appearance recognized around the world. Every rivet, every panel, every connection is measured to microscopic accuracy. Nothing escapes this inspection. But here's where everything changes. Thousands of hydraulic components must work together perfectly, or the airplane never flies. Watch closely. Every moving surface must respond instantly. Even a tiny delay at 40,000 feet could have serious consequences. The aircraft's digital brain finally comes alive, processing thousands of signals every second before the engines are even started. Everything you've seen so far was only preparation. Now the heart of the aircraft beats for the very first time. One tiny mistake here could destroy engines worth tens of millions of dollars. Every sound, every vibration is carefully analyzed. Thousands of sensors reveal secrets invisible to the human eye, and the next discovery could determine whether this airplane moves forward. After months of engineering, one unforgettable moment arrives. For the first time, this giant leaves the factory and meets the open sky. But don't celebrate just yet. Building an airplane is only half the challenge. The most important journey is about to begin. For the first time, this giant moves under its own power. Every meter reveals new data, and engineers are watching every single detail. Even at low speed, every vibration, every sound, and every system is carefully measured before the aircraft is allowed to fly. But here's what passengers never see. Hundreds of engineers are monitoring this airplane from the ground in real time. This isn't takeoff, not yet. It's one of the most demanding safety tests, proving the aircraft can stop even at incredible speed. Temperatures soar, brakes endure enormous stress. Yet every component must perform flawlessly before the next stage can begin. Everything you've seen so far has led to this moment, the first flight that will determine whether years of engineering were truly successful. Against all odds, hundreds of tons leave the ground. It's a breathtaking moment, but the real challenge has only just begun.
High above the Earth, test pilots intentionally push the aircraft through demanding maneuvers that ordinary passengers will never experience.
Every response is recorded, every movement analyzed, because the smallest abnormality could change the future of the entire aircraft. The first flight is complete, but Boeing's toughest challenges are still ahead. Before this aircraft can carry a single...
The localized stress reading on the fuselage is spiking right here.
Yeah, I'm tracking it. Let's cross-reference with the thermal overlay.
But here's what surprises most people. These wings are intentionally bent farther than they'll ever flex in normal flight. Every fraction of a millimeter matters. If anything behaves unexpectedly, engineers stop the test immediately. However, freezing temperatures are only one challenge. This aircraft must perform whether it's above the Arctic or crossing the hottest deserts. From freezing ice to blistering heat, every system must work perfectly. Nature offers no second chances at 40,000 feet. And this is where everything changes. Storms that would keep most aircraft grounded become another test Boeing must conquer.
Strong crosswinds push against the airplane with incredible force, but skilled Caucasian female test pilots deliberately fly into the challenge.
Months of engineering now depend on one final verdict. Every document, every inspection, every result must be perfect. After years of design, millions of parts, and countless tests, this giant has finally earned the right to carry passengers around the world. Its journey inside the factory is over, but a far greater journey is about to begin, and what this airplane will experience over the next decades is even more extraordinary.
After years of engineering, this giant finally carries its first passengers. But every successful flight begins with, for most travelers, it's simply another flight. Yet behind every seat lies millions of hours of engineering, testing, and human dedication.
Within hours, this aircraft connects countries, cultures, and families, making the impossible feel completely ordinary. However, every flight is only possible because thousands of specialists around the world work together with extraordinary precision.
We should optimize the thrust vectoring on the tail section. Agreed, run the simulation. And let's increase the bypass ratio here on the engine intake.
Automation, artificial intelligence, and advanced robotics are transforming the factories of tomorrow, making every aircraft safer and more efficient. The airplanes of the future may look different, but they'll still depend on the same relentless pursuit of engineering perfection. From fragile machines made of wood and fabric to giants carrying hundreds across oceans, aviation has transformed the world in just over a century. Every rivet, every engine, every test, every engineer, together they make one extraordinary achievement possible. The next time you see a Boeing aircraft cross the sky, remember that behind every flight is an incredible story of innovation,